I'm Jim Kafka, Optica president for this year. It's a pleasure to welcome you all here, colleagues, partners, fellow builders of the photonics economy. I spent the last 4 decades working with lasers. I'm still amazed at the rate at which our technologies move out of the lab and into the critical infrastructure. And a journey that many of you have undertaken as well, and you know it's often not smooth. If there's one word that defines our operating environment right now, it's uncertain. We're all facing rising geopolitical tensions, sudden shifts in trade policy and global investments, talent restrictions, and conflicting signals from financial markets. And yet, even in this turbulence, our global photonics industry remains indispensable. And that's why trust matters. To quote Jose, not the easy kind of trust built in times of shared success, but the deliberate kind of trust, forged through genuine collaboration in these complex times. But that's also where Optica, and especially events like our Global Photonics Economic Forum, plays a vital role.
This is 2 very intense days, 2 fantastic days. I'm having the time of my life. And I think many of you as well. The next session is, in my opinion, the most important session of this conference. We are going to talk about geopolitical trade. And for that, we have a panel discussion with some of the best panelists that we could find with the authorized voice to discuss this very important topic. But in a discussion with one of the members of the Board of Trustees, with Chuck Mattera, Chuck said to the rest of the team that there has to be an introduction to set up the scene. It took us a long time to find the person that had an authorized voice and no fear of telling their truth. We went to McKinsey and we got the expert on supply chain resilience and geopolitical trade from McKinsey. And we are happy to say that we brought him here all the way from New York for telling us his vision, his hope, his idea, and his knowledge on the current geopolitical trade. Abhijit, thank you very much for coming to Malaga. The floor and the attention of everyone is yours.
Thank you, Jose. I'm delighted to be here. My name is Abhijit Mahindroo. I'm a senior partner at McKinsey. I co-lead America's semiconductor practice. Just arrived here, but I saw enough of the videos to know that this is the introduction Jose has been giving every session. Every session is the most important session. But I'm sure they are. And I'm also interested in seeing how these themes are crisscrossing, how supply chain discussion becomes a discussion on technology development, on geopolitics, on a whole host of other issues. And so when Jose said I should talk about global supply chain challenges, I thought this audience may not be interested in the comparative benefits of different supply chain software and what each of them does or doesn't do. But I thought the room might be interested in asking some very fundamental questions. And the question that I want to pose to all of you, is the world still flat? Show of hands, how many people have heard about the Golden Arches theory? Jose has. Not many other people. All right. So the Golden Arches theory that was articulated back in 1996 by Thomas Friedman basically said no 2 countries that have a McDonald's have ever fought a war with each other. And the theory was basically saying that people who are part of the same supply chain have shared economic interests, and over a period of time, they will find a way to cooperate. And for a long time, the theory was true, but then more recently, things have happened that are leading us to question, does this line of thinking go and sustain itself into the future? Tom Friedman wrote The World is Flat in around about 2005, 2006. And this was basically an ode to globalization. He talked about globalization 1.0 and how, countries globalized, and he talked about globalization 2.0, companies globalizing. And then like a new, good columnist who has to write a book every few years, he talked about globalization 3.0, which was basically people globalizing. And while describing this feature, he talked about what he called a few flatteners that were characteristics of this flattening kind of world. So what were the ones he talked about? He talked about the age of connectivity. This was around the time when the internet had basically exploded and businesses were getting formed. Netscape had released, had gone public. He talked about the age of creativity. and he talked about how the walls had come down. This was in reference to the Berlin Wall coming down. And he talked about Windows going up as the Windows operating system became quite paramount. And then, of course, he talked about offshoring. He talked about the rise of China and its influence on global economies. So we're going to spend a few minutes looking at each of these trends, and we're going to ask ourselves which of these remain true and how they are getting modified in the years ahead. So the age of connectivity, at least our belief is it is being replaced at this point by a new age of intelligence. Now, all of us have been playing with ChatGPT since it came out, and it has been making remarkable progress in terms of its capabilities and what it can do. What you see here is the progress that basic foundation models have made between 2022 and 25. Now, when you look at this, you see medical benchmarks or bar exams and code generation capabilities. I will tell you, I have doctors in my family, I have lawyers in my family, I have software writers in my family, and when I see this, I'm not surprised. This can happen. But what really surprised me this year was that the models are now beating the IIT exam. They're beating the China National Entrance exam. They're beating International Math Olympiad standards. They're beating International Physics Olympiad standards. Something that can do that is intelligent. Something that can do that is unplugging a new capability. So what is the foundation of this new capability? An important point to note, and again, this is one of our estimates, is developing this intelligence capability over the next few years, setting up the infrastructure that will be behind it in terms of data centers, silicon, utilities, energy, the whole enchilada, is going to cost something like $7 trillion over the next 5 to 6 to 7 years. Now, just to put $7 trillion in perspective, the entire Manhattan Project was $30 billion in today's money. The entire Marshall Plan for the rejuvenation of war-affected economies in Europe was $150 billion. The Apollo moon landing was $280 billion. All of this is in today's money. The entire internet infrastructure that was built over 96 to 2001 cost close to $1 trillion. FDR's New Deal, $1 trillion. The Belt and Road Initiative so far, $1 trillion. We are projected to spend 7 times the amount of the largest investments that have happened in a consistent way over the next 5 to 7 years. And this investment is coming not necessarily from governments who are going to run massive deficits. These investments are coming from companies that are amongst the most profitable in the world today, have balance sheets and P&Ls that can sustain this level of investment as long as their revenues continue to grow. There's a profound difference that gives tailwinds to this level of investment that we are going to see. Now, what is the impact of that to semiconductors or photonics? As you've all been seeing, we are entering, at least where AI is concerned, an annual innovation cycle. You've had essentially Jensen releasing a chip every year. And what he's releasing is increasingly not just a chip. It's a bunch of associated stuff that goes into a server, the connectivity along with it, the power management along with it, the thermal management along with it, eventually the utility infrastructure that will be required to continue to bring power to it. The knock-on effects of this innovation go far beyond the semiconductor chips that are going to sustain it. Now, what does an innovation cycle like this do? Instead of projecting, let's look back, because this innovation cycle has happened before. For the last 18 years, there is a device that everybody has that has, on a serial click, year on year on year, been delivering a new device. So what does 18 years of an annual innovation cycle actually accomplish? That's the iPhone in 2007. That's the iPhone in 2025. It becomes a little larger. It becomes a little lighter. It comes in flashier colors. So it looks pretty interesting. But what this hides is what happens underneath. In terms of technology, today's iPhone is 10 million times as powerful as the original iPhone. In terms of bandwidth, it's 10,000 times faster than the original iPhone. In terms of memory capacity, it's 60 times. Supply chain. First weekend sales of the iPhone today are 137 times what the first weekend sales of the original iPhone were. Imagine what that means to global supply chains in the level of integration, in the level of roadmap alignment, in the level of long-term thinking that a bunch of distributed suppliers across the globe are doing to continue powering this. Lifetime sales have gone 30 times. And then, of course, the value that's been created on top of it. App revenue today stands at 1.3 trillion. That's larger than the GDP of several economies. It's amongst the market cap of the largest companies in the world. That's what 18 years of an annual innovation cycle accomplishes. How does it happen? Software-defined architectures, hardware-enabled performance, modular integrated design, new physical digital interfaces, intelligent power management. As semiconductor companies, we've been hearing this for the last 18 years. I am pretty sure, as photonics companies, you're hearing these principles increasingly from your customers. So, we just did some projections. We picked up today's servers, and we said, what happens if 18 years of incremental innovation happens on these servers? And the numbers are fine, but what it's actually equivalent to is all human brains running together simultaneously. It's like a semantic search on the entire Library of Congress catalog. It's like recording every single video ever created until today on local storage on a server rack. It's like instantaneous brain-to-brain communication across continents. It's consuming as much power as it takes 4,000 homes today. That is the level of innovation train that we are on if this infrastructure keeps on moving ahead the way it is. That is the kind of supply chain that needs to get built. So Tom Friedman then talked about the new age of creativity. I think what we are also entering, as many speakers have talked about, is the new age of conflict. I'm going to show you a sobering statistic. The world is becoming a much more dangerous place. It's now experiencing the largest number of state-based conflicts that have happened in history since World War II. What I'm showing you here is casualty figures, deaths in state-based conflicts. And since the start of this decade, we are pretty much tending towards levels that were last seen during the Vietnam War, that were last seen during the turbulent 80s with Middle East crisis, the South Sudan civil war. Unfortunately, this is just an upward and increasing trend. The nature of conflicts is changing. Old orthodoxies are getting broken. These are quotes that were very relevant recently. Prospect of a major war in Europe has become so remote that it's no longer a serious probability. Presence of nuclear weapons makes wars between states that possess them less likely. Most non-state actors lack the skills and the training to operate advanced weapon systems. These basic principles that guided the tenet of war fighting, and more importantly, military supply chains, military development, are breaking down completely. So what does that mean? That means the world is spending much more on defense technologies than it has in the recent past. That acceleration is already visible, and with the commitments that have been made, including in Europe, it is only going to speed up further. What is interesting, though, is increasing amounts of that money are going towards platforms and technologies that are very different from what they have been in the past. Most military expenditure used to be on fixed assets, large assets, salaries, barracks, stuff like that. Today, 90% of all Ukraine strikes on Russian systems are coming from FPV drones. Ukraine is going to procure somewhere between 4.5 to 5 million of FPV drones over the next year. And what happens when you look at these systems? Essentially, 40 to 60% of electronics is 40-60% of the BOM is increasingly electronics. It's not metal, it's not fuel, it's not other systems. It's electronics, it's photonics, it's systems such as this. And what are the underlying principles? Software-defined architectures, hardware-enabled performance, modular integrated design, new physical digital interfaces, intelligent power management. It's the same design principles that were applied to the iPhone that you're seeing applied increasingly to integrated architectures in defense. Now, design is getting sped up. The question that we should ask is what happens to scale up and what happens to manufacturing? I don't know if you folks have heard of Charlie Sorensen or if you've heard of Willow Run. When the US entered the Second World War in 1941, it was not a war economy. It was barely producing war materials. But in the next 4 years, they ramped up to such an extent that during the period of the Second World War, 1/3 of all aircraft that were produced globally were produced in the US. One of the people who did this was Charles Sorensen. He was essentially a production engineer at Ford who looked at how cars were made and essentially picked up the techniques of just-in-time production, assembly line design, operations research, and applied them to military production. To the effect that by 1944, the Willow Run plant, which is a plant in Michigan, was producing a B-24 bomber aircraft every 63 minutes. German intelligence actually got a video of this plant. They were scared to show it to the generals in Hitler, fearing that they wouldn't believe it. That's the kind of scale-up that these existential crises lead to. That's the kind of production scale-up that is needed to refine production of these advanced systems. Where are we on this? How are we going to be able to replicate things like this? Finally, Tom Friedman talked about offshoring. And I think we're entering a world of multi-shoring. A move to China is being replaced by multiple new things. It's being replaced by China plus one. It's being replaced by China for China and then Chinese FDI into other countries. And of course, it's being replaced by reshoring, where a good deal of investment is flowing back into advanced economies. And the numbers are bearing this out. The policies are bearing this out. CHIPS Act, other investments are encouraging things like that to happen. But two questions that we should keep in mind. One, you see the rise of Chinese systems, not just Chinese components. And I think electric vehicles, particularly here in Europe, you get a frontline view of this. To give you a sense of the numbers, electric vehicles have expanded from 500,000 10 years back to around 20 million cars being produced annually. 60% of that are made by Chinese OEMs, either in China or globally. The level of automation and efficiency that they've brought into their production manufacturing systems candidly reminds me of Willow Run. If you look at the BYD factory, this produces every 60 seconds a BYD line rolling off the assembly line. How does that happen? Just an amazing degree of vertical integration. And this is just physical components. We're talking batteries and the chassis and stuff around. This actually goes down increasingly into semiconductors, into photonics, into other aspects. If we believe that that will not happen, I think we are just deluding ourselves. At the same time, there is a question around reshoring back to Western economies. And if you at least believe the announcements that have been made by several companies around leading edge manufacturing, in around 10 years' time, the US would have shifted back close to around half of share of the world's leading edge production on advanced semiconductor technologies. The challenge is that even in the best estimate, even if you were matching the yields that you're producing in Taiwan, the cost of manufacture is going to be 20 to 30% higher than what you are able to do in Asian economies. And so replicating the way things are done is not the answer. Building this infrastructure in new ways, with changes to the supply chain, with changes in level of automation, with application of AI towards product development and deployment, has to be the answer. As we build these capabilities, they have to be built differently, and they have to be built with future-looking products and architectures in mind. It may be time for another Willow Run moment. And so as we move to the next panel, I encourage us to think about, is the world still flat? The age of connectivity has been replaced by the age of intelligence. The walls that went down, well, new walls are coming up in different parts of the world. And the move to China has been replaced by a whole host of multi-shoring initiatives that are going to affect all of us in this room. That sets the stage for the next session.
Good to see you. Thank you very much for such a great presentation. Many of you have been texting me during the presentation saying, wow, can I get the slides? Can I get the slides? You're going to get the slides. And also, I would like to remind everyone that this meeting is live stream in YouTube, which means it's also on demand in YouTube. So you can watch, rewatch, and forward that presentation to all your colleagues. What a big present, eh? Right now, we have a very important part. I know I say this a lot. We have now a very important part of this event. We are going to talk about geopolitical trade. And to moderate this panel, the team of trustees could not find a better person than Anthony Yu, former vice president of GlobalFoundries. Anthony, this is your panel and your stage. The floor is yours.
participating with them.
Me? Can you hear me? So good morning, and thank you for being here. First, a couple of program notes. Cameron Carr from Flextronics unfortunately won't be able to join our panel today. He had a family matter. He represents Flextronics in a very significant EMS presence. We will still continue the panel without him, but we wish Cameron well. Second program note is, while it states that I'm GlobalFoundries, I should remind you that I retired from GlobalFoundries about a year ago, and I'm spending my time partially retired. When I'm not traveling or spending time with my family, I'm a part-time consultant. I'm on a couple of boards, and I advise companies on how to bring products to market, particularly in the photonics industry. Those discussions as a consultant and advisor have been centered around the current environment of tariffs, H-1B visa restrictions, and of course, geopolitics as defined by our fine speakers yesterday and Michael Hochberg's model in particular. But those problems, while they are frustrating and often emotional and very, very hard to predict, are business problems for our leaders to solve. And as we've seen over the last day and a half, CEOs and business leaders are stepping up and finding ways around that. So I'm really pleased to have you introduce yourselves to our panel, have them tell themselves to you today. Each one of these panelists represents a different value point on the chain of bringing a product to market. You've got a variety of perspectives. Each one of them is unique, and they tell a good story. So with that, I'd like to have the panel come up. Guys. All right. This is a great group. You're really going to enjoy this. We curated them specifically, and I've had many conversations with them, and they'll share their perspectives with you. Why don't we start off? We'll start off with you, Luke. We'll go one down here. Just to state your name, maybe a brief description of what you're doing and what your company's doing, and then we'll proceed with the panel.
All right. Thank you very much, Anthony. Real pleasure to be here. My name's Luke Scrivenich. I'm the general manager of Viavi Solutions, optical security and performance products business. Viavi is a public company, 1.1 billion in revenue, nearly 4,000 employees. We have 60 locations in 40 countries around the world. That's important because we're going to discuss global footprint later and the importance of that in supply chain resiliency. There's two reportable segments for Viavi Solutions. We have a network and service enablement business that makes test and measurement equipment and quality assurance solutions for telecom, datacom, and avionics. And then the business that I'm responsible for, OSP, optical security and performance products. This was really based on the technology that was originally developed by Ockley Optical Coating Laboratory, Inc. And Rochester Photonics. We make passive optical components that are used in applications like optical interference filters, engineered materials, and light shaping optics, various end applications in currency security, consumer electronics, automotive sensing, defense, aerospace, and spectroscopy. And just one final note, real excited to be here at this conference. I didn't attend last year's conference. I see this industry, photonics, as being at a critical inflection point. In fact, I'd assert even past the inflection point, with photonics being a key enabling technology, foundational technology for a number of these trends that we see in the market, from datacom to free space optical communication, to quantum communications, onto laser inertial fusion, which hopefully can solve some real problems the industry has in scaling some of those technologies. And so I really saw the 20th century as being the age of electronics, the 21st century, the age of photonics. So real pleasure to be here.
Hello, everyone. My name is Kevin Luke. I'm a co-founder and head of custom development at Hyperlight. So Hyperlight is an earlier stage company. We focus on thin film lithium niobate, which is an emerging photonics platform. The advantage of this platform over traditional silicon photonics is that we can achieve much lower power and higher speeds. So for this new inflection point that Luke mentioned, where we need higher networking bandwidth and higher scaling, our platform has major advantages there. And to do so, we also have to integrate with new supply chain partners. And so that's where we're here to provide our perspective. We currently serve a variety of markets. So earlier entry is into telecom, and then now looking at datacom. We also have applications in a variety of markets, such as quantum computing, where they have requirements for very low loss and very high speed. And so really there's a variety of applications that are emerging that we believe we can service.
Christoph.
Hello, everyone. My name is Chris Fistner. I run sales and marketing for Avicenna. We are the pioneer of micro-LED interconnects. That is a new type of interconnects, ultra-low power, compared to the traditional laser-based interconnects. It's ideally suited for chip-to-chip and chip-to-memory connections because of its low power and its footprint. Basically, the way it works, we take an array of LEDs. It's transferred onto a CMOS chip that has all the driver functions, goes through a fiber bundle, connects to another CMOS chip where we have the receiver with the PDs, and then you can use any electrical interface that is needed to connect to your host. We're also at the earlier stage. We're at prototype stage currently. We are located in Silicon Valley, but we also have a subsidiary in Europe. So we're already looking at the global footprint here. I'm looking forward to the discussion.
Okay, my name is Lutz Aschke. I'm representing Photonics 21 and myself. So Photonics 21 is a public-private partnership, which is the connection between the photonics community in Europe to the European Commission. So membership is free. It's an association because the European Commission funds us, and we collect on democratic principles the priorities of the photonics community in Europe, which is industry and also academia. We do the, let's say, strategic research agendas for the next couple of years, and the European Commission consumes that and makes the funding calls for the next few years out of that. So since that is an honorary position, I held for the last 25 years different C-level positions in the photonics industry, lithography, high-power lasers, these kind of things. I'm currently doing consulting in M&A cases for strategic and private equity investors, and also on an interimistic basis support companies in special situations like turnarounds, but also strong scale-up situations, which keeps us busy because sometimes these things happen at the same time.
Yeah. Abhijit, you had a 15-minute introduction, but you can say a couple words about yourself.
Abhijit Mahindroo with the McKinsey Company. We're a global management consulting firm. We'll be celebrating our 100th anniversary next year. What do we make? My grandmother asked me that question when I joined consulting. I still haven't been able to answer. I think we make two things. We make ideas and we help companies drive change. And in times like this, when change is hitting us from all sides, I think the work takes on special relevance.
Okay, so the times like this, I can't think of a better way to describe a very unique, dynamic, and challenging time. We could spend an hour on every one of these topics, but let me ask you, Luke, to be brief but impactful. What do you tell your customers in this environment where literally, when you turn on CNN, the business environment could change overnight? How do you manage expectations with your customer?
That's a great question, Anthony. I think Jen Cable said it great. You don't want to be reactive. You want to be thoughtful and then respond. So that's the first thing. Let's not overreact to the challenge. And clearly, we want to balance our desire to delight our customers with the need to navigate a very challenging global trade environment. And so the importance of the investments that Viavi's made, hundreds of millions of dollars of investments in bringing up manufacturing capability and the associated supply chains that are distributed around the world so that we can serve our customers in their local ecosystems. That's been very important, and it's really allowed us to significantly mitigate the impact of the tariffs. Another key aspect, so you really have to think strategically, but you have to behave locally with your customers. So that's another big aspect. Another thing is to effectively communicate, be very open and honest with your customers and your partners.
I will note, Luke, that your CEO in the last earnings call admitted that tariffs were probably going to cause price increases.
Right, exactly.
That was a courageous move, but very, very upfront.
Right, and so we were able to mitigate that partially through developing additional supply sources, but we also had to pass along some of the price increase to our customers. Very honest about that. And so that's clearly how we're trying to communicate with our customers and really trying to balance the needs of serving them along with trying to mitigate a very challenging global trade environment. So thank you.
Kevin and Christoph, you guys just came back from a incredibly successful ECOC. You're probably doing a victory lap around the building. Kevin, with your driverless 110 gigahertz thin film lithium niobate, find a way to deliver 400 gigabit per lambda for the 1.6 and 3.2 terabit. It's a fantastic modulator. Congratulations. Christoph, micro LED, 200 femtojoules per bit, the lowest energy efficiency possible. That's fantastic news. But you're both disruptors in a very, very challenging environment. It's hard enough to go from prototyping to scale, as we've heard over the last 2 days. What's your perspective? I mean, you're still here. You guys look great. You look energized. How are you going to work in this environment where we have tariffs, visas, geopolitical tensions, everything else? Tell me what's on your mind. Kevin, you go first.
Yeah, it's a good question. The situation is rapidly evolving. We're in a time where things are shifting, every couple of days in some cases, in terms of policies. I think from our side, we're very focused on delivering value to customers, and how to do that in this changing environment, it really depends. When we talk about shifting geographies, for example, within the supply chain, it's never just about the geography. It's really thinking about a long-term optimization of cost, speed, and quality, right? And so in some cases, that makes sense, but a lot of this is industry specific. So for the photonics industry, actually, it's quite different from electronics industry, where there's a lot of mature infrastructure, mature processes. Supply chain is already quite robust. It's a lot easier in some ways to replicate and diversify that supply chain. Whereas photonics, we're still in this stage where you almost, in some cases, need to know the fundamental physics to really drive value with the suppliers. And so in that kind of environment, we need really strong partnerships with our suppliers, because we really need to almost co-develop in some cases the value for the customers. So with that said, to do that, we are really focused on creating really strong relationships with our suppliers and also our customers. And in some cases, changing geography may not be the optimization, at least at this stage. Sometimes working with the single supplier and really generating a lot of value with them, that also then shifts the benchmark for when we need to go to a second supplier, because we have the depth of understanding to evaluate other suppliers. So I think that's kind of how we think about these problems, but it really comes down to understanding your suppliers, building those relationships, understanding what your customers, care about, and also working with them to solve really their underlying problem and deliver value to them.
Thank you. Chris.
Yeah, so similar situation for us. We have advantages that we are mostly outsourced. So again, we work a lot with our partners. Our partners have global footprint, so that can help with mitigating some of the shifts in the supply environment. We're working very closely with our customers, delivering to what they need. Again, this low power, that's what we showcased last week. This low power approach is there's a huge demand on that, as we all know. AI is driving the power consumption in data centers globally to unsustainable levels. Another big advantage we have is the bandwidth density that people are looking for when they're networking their chips, future AI clusters in general, and their applications beyond that. We also have the advantage that, for instance, for our light source, we have an internal supply capability in addition to our global partner for the volume scaling. So that helps us as well. So with all this, we're working through the challenges and just make sure that we deliver what customers are ultimately looking for.
I see. Now let's go one level lower now, because you can't build products without materials. You can't build, then the unique materials in photonics make it a particularly challenging thing. Abhijit, from a macro level, what materials do you see as you talk about your concentration? What do you see as being particularly subject to constrainment in photonics?
I think specific to photonics, what worries me most are gallium, indium. I mean, if you look at these raw materials and you see how much of the supply is concentrated in certain regions, how much of the processing capacity is concentrated in certain regions, and how significant they are to many of the applications that we're talking about, these will be challenging. Alternative supplies need to be developed. I think the other piece that we've learned, particularly in the semiconductor supply chain also, that is very tough to replicate is equipment and specific processing capabilities, different kinds of advanced manufacturing capabilities. And that presents a different kinds of concentration. But, the risks, particularly in an environment where trade flows are subject to, new rules, new tariffs, become very pronounced.
Yeah, very good. So you answer the phone every day. How do you manage these types of shortages or potential shortages or exposures, Luke?
Yeah, so first of all, in terms of substrate, for us, it's always good to develop multiple sources. I mean, that's the ideal situation where we have multiple sources and we have some redundancy in our supply chain. And so that's the first course of action. But there's some cases where there is no second source. And so we have to work collaboratively with our customers and really try to stand up.
Does that mean stockpiling? There's no second source?
No, there's
collaboration mean?
Well, collaboration means trying to qualify a second source, not stockpiling. We'd like to try to avoid the stockpiling, to try to qualify a second source or to do a redesign. And that's, I think, one of the real things that, tools that we have as an industry is you have to innovate to really look at opportunities to do a redesign and some substitution of a rare earth material, for example, that you can't source, and to try to find an alternative for that. You have to work collaboratively, with the customers in order to make that transition to the alternative solution.
Abhijit, there you go. We're innovating to try to find a way around the material shortages. All right, so we use the word global a lot, but we're here in beautiful Spain. We're here in Europe. Lewis, I'm so glad you're on this panel here. You listen to all this stuff happening here. I saw a paper that I think you wrote, or somebody in your organization wrote, was called Invest in Light or Live in the Dark. All right, that's a great opening. So Lewis, tell us about Photon 21. You hear the landscape here of these young disruptors as well as the established people. How does Europe figure into all this? And tell us a bit about your activities.
So basically, photonics is an SME-dominated community, except for some of the semiconductor topics where you have the big players. It's SME-dominated. So the ecosystem has some other rules. And what we see is, of course, we see things like the CHIPS Joint Undertaking, the European CHIPS Act, and it puts a lot of money into re-establishing something that we lost decades ago. And we have a different and much better situation in photonics because Europe is still among the leaders in many photonics topics.
Could you clarify something for me from an earlier panel? So photonics considered part of semiconductors, or is there an implication of a separate category in your perspective?
Well, the semiconductor part is part of the photonics thing. I mean, it's a new thing because the CHIPS Act takes special care of integrated photonics. But that's good that the European Commission acknowledges that photonics is relevant in the next generation semiconductor ecosystem. And the next generation CHIPS Act will have a stronger emphasis even on that. But we have a functioning, vital, and industry-leading ecosystem in photonics, and it's much easier to maintain that than throwing billions on something that we lost a decade ago, right? And so that's why we're saying let's keep that ecosystem alive. Don't forget that we are already strengthen your strengths. That's basically our message. And we have world-leading companies, also SMEs, but also big companies in Europe. And we should not forget that that we should maintain that, and that will also be beneficial for the semiconductor part. That is of course important for the resilience of the European industry. So that's why we think key enabling technologies always have an issue with being digestible for politicians. And so it needs a lot of communication, and that's why we send these strong messages, and we feel we've been heard, but that's also something I like to have your support, because talk to your member states. If you're based in a European country, talk to your politicians and make sure that they convey the message via their politicians in the European Parliament to the Commission. Because in Europe we have the thing that there is a European Parliament and we have the Commission, and they're kind of disconnected sometimes, and having that influence from that side would be very helpful.
I heard some frustration at an earlier panel when one of the gentlemen said that there was no packaging in Europe. From your perspective, from Photon 21, are you looking at everything from crystal growing substrates all the way through packaging? What areas in particular are you looking to maintain? Because I would challenge you to say you can't maintain something if it doesn't exist in the first place. So what are you focusing on?
I think for all these things, there's still the know-how there, but I think we lost the ability to scale. So crystal growing is part of that. There is still something in Europe, but it's small compared to China, and it's just because we just left it over to them, and re-establishing them. That will cost us some money, but it's still something we can do. And I think on the machine part, we have a good tradition in Europe, being leading in that part, so that's good.
Sure.
And all the other things, we have an excellent university ecosystem, all the institutes we have in Europe. So everything is there, but we need to reestablish a more aggressive way to be able to scale. And I like that thing that we heard yesterday. That is, if you're not able to scale, the next thing you're going to lose is innovation. And I think now we need to act.
I'll tell you, I retired from GlobalFoundries, of course, but in the course of my career there, I traveled many times to IMEC, to Leti, to the what's happening in Switzerland, Germany, the innovation, and of course what's happening in the Netherlands. The innovation in photonics in Europe is impressive. It's impressive. But these two young gentlemen here, as you now go to the next phase of prototyping, sampling customers, and then moving to production, I'm going to put you on the spot. Christoph, you first. You've got a presence in Edinburgh. Do you feel supported in Europe? Is Europe factoring in your plans to introduce your products either through prototyping or volume? You don't need to disclose proprietary plans, but talk to me about how you would view Europe as the opportunity, given what Lutz has talked about, what he wants to do here.
Yeah, no. So this is it's a very good question, and we do see great capabilities in specialty applications, and we actually leverage that. we are still looking on, and some of it looks promising that we can actually scale that as well. But there's definitely still some work left to be done. But then we're combining it with our other capabilities and our other partners, and we're getting a good ecosystem. So we're cautiously optimistic on this, but not everything is completely.
All right. In a perfect world, if Lutz had a magic wand that could do things for you, what would you want Europe to do to allow you to shift your plans there for production?
Yeah, that would definitely be the scaling it up, and we're not just talking semiconductor foundries. We're also talking about different aspects of fiber connectivity, where we definitely see a good base and a lot of specialty capabilities that would help us.
Kevin, how about you? Same question.
Yeah. So Europe in general has always been a fertile ground for photonics. We do see, we actually have some early evaluation of suppliers here in Europe as well. I think there's there's several different photonics companies. There's a big diversity of different approaches going on here. I also think actually the talent pool is quite good here. There's a lot of education and strong facilities here for education. I think the challenge though that often comes with diversity is there could be a lack of focus in some cases where for strong supply relationships, it does require a deep co-collaboration with and also a longer scale partnership or longer time commitment. So like to give a concrete example, for our foundry partner, to train them on photonics, as I mentioned, kind of photonics is in this stage where you still need to understand some of the underlying physics. It's not abstracted to the scale that electronics is, where you have a transistor and you have it fully characterized, and now you can make all higher level logical circuits. So with photonics, when we're just talking for manufacturing and producing high quality devices, you tell them about, you can lay out all the specs, critical dimension, et cetera. But when you tell them this, and then you tell them, I want this large feature, but I need very low line edge roughness, right? That doesn't make sense in traditional electronics, right? But it is something for people trained in photonics that's a very fundamental to how the device operates. So I think this kind of intuition, us learning how the manufacturing side works, how they think, them understanding how the photonics thinks, that depth of collaboration and also the time scale for that commitment is what's necessary to really drive value. And especially as we have these new emerging opportunities, AI is really, kind of revitalizing the photonics industry to really capture these industries and opportunities in the time scale needed. I think Abhijit showed it's now an annual release of the new NVIDIA architectures. To really do that, we need a long-term commitment and a really co-development. And I think Europe is a fertile ground for that, especially considering all these geopolitical tensions between US and China. Europe is a very, a ripe opportunity to kind of leverage that. So I think there's definitely opportunity, but I think it would help to accelerate the timescales and also the depth of the commitment and collaboration.
Maybe I can add something, because I think the strength of Europe is that we have a very diverse landscape of different economic systems here. So being fast, I think Malaga is a good example we have a lot of regulations in Europe, too many. And I think it's best practice here in the area of Malaga that the local government really helps the companies and new ventures to get around it or to find a solution, really a solution-oriented support from the political landscape. Another example is that I would put a bet that building a laser in Lithuania is not more expensive than building the laser in China. There's a great talent pool. It's still affordable to hire those talents. And we have all that landscape here with very different countries, but under, let's say, some guidance of the European Commission. And that's a strength.
Abhijit, you see the landscape here. Policies are still forming. Regulations are still being contemplated. We've got disruptive technologies poised for introduction. What advice would you give? I'm getting free McKinsey advice here. This is terrific. What advice would you give this panel in terms of how to operate in this environment, given history?
Look, I think Lutz talked a lot about the government side of things, and folks talked about local aspects. The 2 or 3 things I would add. One, I think the power of alignment to where the puck is going or where the mega trends are right now. You talked about how AI is being totally disruptive and creating a need today and in really rapidly accelerating product innovation cycles. We talked about how defense is perhaps one end market that wasn't as prominent in the past, but has an insatiable hunger today for new technologies to not just get integrated, but actually deployed in the field with real-time feedback on how things are doing. The power of aligning to pressing needs and then driving rapid innovation on accelerated timelines is tremendous. And if you have technologies that enter or can be relevant to those value chains, you shouldn't be sitting on the sidelines. I think the second aspect that I would add in addition to this is in times of turbulence like this, established supply chains, established value chains see a lot of ferment. And I think having a mindset that we are this kind of a provider, these are our sets of customers, this is how we interact with them, that dynamic changes. The need for new technologies to be available to OEMs or system integrators much faster, have direct access, have a role in investing in those technologies and actually helping suppliers scale up is tremendous. And we've seen it across industries. When there is a pressing need, there are opportunities for investment, co-development that traditional value chains don't allow. So I think breaking out of this mindset of where you are placed and being open to the idea of engaging with the value chain in very different ways is another aspect that I would recommend.
That's very sound. It's very sound. I want to leave room for some audience questions, but I'm going to play a game here with these guys. They don't know this yet, so prepare to surprise. We're going to do a lightning round here. I'm going to give you guys a question. I want a concise, crisp, provocative answer, and then give us your final thoughts, and then we'll go to some audience questions. So Lutz, I'm going to turn to you here. So in the United States, there's a lot of controversy about a $100,000 fee for H-1B visa, and there's a lot of focus on immigration. With that kind of restriction potentially for H-1B visas in the US, is this an opportunity for Europe to capture some of that intellectual talent that could otherwise would not be in the United States?
It is an opportunity. I'm currently supporting a startup that has the culture already of hiring those kind of people who are frustrated by these circumstances. And I think all the companies, and especially also the educational system here, should take that opportunity and collect these talents.
Okay, good answer. Christoph, we turn on CNN tomorrow and President Trump announces 100% tariff on semiconductors. What do you tell your customers in the next 48 hours? What's the delivery to them?
Okay, excellent question. Well, if we did the planning right, then we have the stockpiles that we can rely on to transition, and then hopefully within short order, these tariffs are going to change again, because that's what they've been doing in the last few months. So, well, that's sort of.
So you basically say, wait till tomorrow, it'll change again. That's your message.
That's sort of the quick answer. But so stockpiling is an important part of the strategy, and then again keeping your supply chain redundant so that you have the ability to move as the need arises. That is the other part to it.
Good answer. Kevin, my Cornell graduate friend. 3 of us here went to the same school. We didn't know each other before that, but coincidence. Kevin, if China restricts rare earth elements, thin film lithium niobate, what do you do?
Yeah, it's a good question. Something also our customers are, wary of. So if there is indeed a restriction, I think you put it, you don't want to be reactive necessarily. So we are being proactive on that side, where we are diversifying our supply chain for some of the key supply risks, and this is one of them. But even still, it would be something we'd have to work with our suppliers there, and also suppliers outside of mainland China, as well as with our customers. And so there might be some resolution that could be a combination of things like passing on some of the costs to customers, ramping up alternative suppliers. These are all things that would be holistically kind of factored into the final decision. But generally, we're trying to be proactive in planting the seed so that we have more knobs to tune to be able to react in these kind of situations.
Luke, from a corporate perspective, how do you organizationally prepare an organization to operate, to be able to capture the phone on the second ring and be confident and clear to your customers? How do you train the organization in this environment?
Yeah, it's a great question. First of all, you never know what's going to happen the next day in the environment we're in. So you have to be prepared. And a quote comes to mind. It was a quote from General Dwight D. Eisenhower, who was the supreme commander of the Allies in the European theater in World War II. And his quote was, "Plans are useless. Planning is indispensable." And so going through that planning process of looking at potential scenarios and that would be impactful on your operation, and then running simulation exercises is something that we do on a regular basis to be prepared for the unexpected. And many times our plans are not adequate. And so we have to think outside the box. And then we do a critique. It's a half-day exercise. We do it for every factory once a year. And we critique our response, and then we improve the plan in the spirit of continual improvement. So I think that tool of business continuity planning is really indispensable, particularly in the day and age that we live.
Wow, very nice. Jose, do we have time for some questions? Yep.
Well, thank you so much for a great panel. I'm Samal Saad, president of Neuron IP. We are just in the supply chain. We are we are developing circuits for high-speed data transmission between optical chipsets and CMOS chipsets or host chipsets. So my question is about actually the semiconductor manufacturing part. As big companies, GlobalFoundries, TSMC, Samsung, they're nearshoring their manufacturing in the US, Europe, other parts of the world. That has pushed China into also accelerate the buildup of their semiconductor manufacturing. How do you see that in near future, intermediate future, impacting the cost competitiveness, supply chain resiliency of the semiconductor fabrication right now? Appreciate your insight. Thank you.
Look, I think in addition, there's been this talk of a lot of capacity being created and therefore what happens to the cost and all. I will say, at least my expectation is, I don't think you're going to see the free movement of products as much as you saw previously with some of these non-trade barriers and tariffs and restrictions and regulations coming. Not all this capacity is going to be freely available to everybody. And so I think we have to think of available capacity in new ways, accessible capacity versus total capacity, and how that is translating and what that does to essentially your cost curves. I think the world just got much more complicated.
May I add something? I mean, you ask about cost competitiveness. Sometimes my impression is we're talking about price competitiveness because it's extremely difficult to compete with a company who doesn't care about making money with their products. And that is the point where really politicians need to step in and do something, because that is a problem you cannot solve on your own.
Hi, I'm Bardia Zeshki. I'm also from Avicenna. So a comment and a question. I think this is a really great opportunity for Europe. We have an office in Edinburgh, mostly to manage our supply chain, which is becoming more and more European-based. And there's three things going on here. First, there's an established manufacturing infrastructure in Europe. We have an official partnership with Osram. They make micro LEDs for car headlights and other places. So being able to leverage that manufacturing chain is really important. Second, you have incredibly bright PhDs in Europe that can innovate as good as the Silicon Valley folks, I think. And the third one is a relatively low cost of labor. Spain, UK, Eastern Europe. So we're trying to leverage that. And as tariffs and dangers go up, Europe is relatively safe compared to anywhere else in the world. You want to comment about that one, maybe Abhijit?
Look, I think Europe has unique advantages, and we see that even in the semiconductor space. There are islands of excellence. These institutional capabilities that are built over a period of time, they last long. I think it's a good time now to get plugged in with, like I said, the drivers of the next round of investments and form new partnerships and coalitions. I think Europe is very well placed for that.
Hi, I'm Hitesh from Fanify. I have a question. So we are an early stage startup. Thanks for touching up on the challenges when you are an early stage innovator. You're trying to fight against the giants. Something that came up is like you want to diversify your supply chain, but for early stage, it's a challenge because you have to be very thoughtful with the money, the capital that you have. So you're actually fighting against giants who have the capacity to have alternate supply chain, but you cannot go and pay a significant amount of money to develop, while being away from, let's say, China or Southeast Asia. What's your recommendation on, because I see that we're sort of stifling the innovation because now we no longer can talk across boundaries. It creates a slowing down the innovation growth and new technologies rapidly being, to a prototype stage where it can be implemented in the real world.
Kevin, you touched on that. You want to expand?
Yeah, no, I've felt that pain firsthand, definitely. So I think as an early stage company, my recommendation would be to focus on creating value for the customers and then let all else follow. So if you're working on something innovative or disruptive, really try to hone that edge that you have. And eventually, when you have customers that really need that product, they can bring in the revenue. And sometimes the customers themselves will drive you to diversify. And they can also help fund some of that diversification effort if that's needed. But yeah, I think once you have a compelling solution that people need, then the diversification can follow. I will say though, along the way, you can find, I'll call them low-cost opportunities to diversify. So you can opportunistically try to evaluate different suppliers, for example, with some kind of sampling program or some kind of prototype development. These are ways you can get insight into not necessarily fully diversify, but get insight into the challenge of diversifying and how much it would cost. And then if the customer later comes back with a requirement to have a diversification, you already have the answer available, and you just need to tell them, here's what it'll cost and here's how long it will take.
Yeah, maybe just building on that for a moment. I mean, the big advantage you have as a small early stage company, you're much more nimble. So you can pivot. And as was said before, with our European subsidiary, we're doing exactly that. So we're partnering locally, and we're taking advantage of these other opportunities, and then make sure you work with your customers. As long as your value proposition stays sound, they're open to taking creative approaches to achieving these various basically second path, if you like.
My name is Guy Ear from Optica Sigma. So thank you for the panelists and this theme. I mean, geopolitical trade and supply chain resilience. I've been listening from the beginning. I hear a lot about Europe and US. As my company is basically manufacturing in Japan, how would you consider Japan as a potential customer or a supplier in your perspective? It's a question that's addressed to all of the panelists here. Thank you.
How do you view Japan?
Yeah, so actually, I'll take that. We have a number of partners, customers in Japan that we do business with today. Also, one of our key equipment vendors is based in Japan. And so we do a lot of business in the country. and want to see if we can grow that business as we advance some of our new business development efforts.
I think when you asked, what are the choke points with respect to supply chain, we talked about materials, we talked about equipment. Both of them, I think Japan is critical for. And so when it comes to developing solutions and alternatives, I think partnerships, Japan has to be an essential part of the solution.
I will say, Guy, that when we started off in photonics at GlobalFoundries back in 2017, 2018, the telecom market in Japan, NTT and people like that, they drove the early products coming out of GlobalFoundries. So I think photonics in Japan is the underpinning of the whole industry. Very strong. A lot of questions there.
Everybody, my name is Luis Rafael. I'm the CEO and co-founder of Femtom. I see Canada, so you can imagine I'm from Canada. Actually, Canada in advanced packaging of silicon photonics is very strong. So JBL is now in Ottawa. You have also Sanmina in Ottawa. You have also IBM Bromont. All the argument I hear about Europe is the same about Canada. I mean, the cost of the people are cheaper, high quality of people. So what do you think first of Canada? And second question is, what I don't see here, and I think it's the biggest guy in the block, is Taiwan. So Taiwan, right now, I've been 6 times in the last 3 months in Taiwan, silicon photonics. CPO is the hottest buzzword in Taiwan. So what do you think also of Taiwan? Because this is the key supply chain for CPU.
Chris, you're doing your photodetectors for at TSMC. Why don't you talk about your Taiwan experience?
Yeah, correct. Yeah, no, thank you for that. And Taiwan absolutely looms very large. It's one of the largest largest footprints for exactly that. We have a collaboration with TSMC for our photodetectors. So that's again leveraging a big partner with a global footprint. Absolutely important. And of course, the founder business goes without saying.
I guess the implied question is, do you think you'll have to diversify away from Taiwan due to geopolitics, or are you comfortable with TSMC?
I mean, what TSMC, for instance, is already doing, they're diversifying away from Taiwan. So they're doing that. They're doing that themselves at a very large scale. Now, for instance, in our case, we have the advantage. We are CMOS compatible with a broad range of nodes. We're not locked into specialty chip configurations. So that is also an advantage for us.
Any comments on Canada as a geography?
Well, I think the politicians they have a word that it's called the like-minded countries. And Canada, Japan, South Korea are among them. So I think it's easy to do cooperations with these kind of countries because it's politically supported, even in terms of public funding for doing things. So that's good. But of course, Taiwan is a very special thing because there are even people around who would say it's almost China, which I don't think. But I've seen so much. I mean, they're so excellent in executing high volume manufacturing on a semiconductor basis. They more or less invented the foundry model, and I've seen many companies transferring their manufacturing to Taiwanese foundries, and everybody of them is considering, okay, shall I pull these manufacturers to Europe, or shall I insource again? And I think every company has to think about how to solve that.
Well, I've just got the hook, so unfortunately we have to stop, but I want to thank my panelists here for a very good discussion and thank the audience for your questions. Very good, and that everyone's available in the afternoon for follow-on discussions. So thank you very much.
Good job.